Hello friends, in this lecture I will explain DHCP protocol. Uh, this DHCP actually stands for Dynamic Host Configuration Protocol. This protocol actually used in order to provide networks detail to a new device. For example, we people are having Wi-Fi network. So whenever you connect your device to that Wi-Fi network, your device automatically get its own IP address. So there must be some uh, device who are providing these details. So in this lecture we will see how DHCP works. So first of all we are taking here a simple example. What is the need of DHCP? So in this example, as you can see, we are having 4 machines. Every machine is having a IP address. So with IP address, in order to connect to a network, we need some other details like default gateway, what is the subnet mask, and what are the DNS address. Sorry. So these all details are required. Let's assume now a new machine is just connected to the network. So a new machine is connected to this network using a wired cable. Now after connecting to the network, this machine has to be configured. When we say configured, it means network IP address, subnet mask, default gateway, all these details has to be filled in, has to be configured on this machine. Now the first option is that the person who is responsible for handling these networking, that person will, so this person will manually configure all the details on this machine IP address. So this person has to remember that, okay, I have allotted IP address till 15, so the next IP address going to use on 16, and default gateway and your subnet mask, so all details will be configured by this person. So this is manual configuration. Now the problem with manual configuration, uh, there are chances of errors. It might be possible that this person forgot which IP address has been already allotted and it assigns same IP address, or while entering IP for subnet mask, or while entering in subnet, sorry, in IP address, it that person might uh, make some error, and this machine will get wrong IP or wrong network detail, and this system cannot access network services. So so this manual configuration has some problems. Because of this problem, so these are the problem we have already discussed. So another solution, which is a better one, so in this solution, whenever a new device is connected to network, that device will obtain all the networking detail from a designated server, and that server is DHCP server. So let's assume here, if this IP is the new one, it automatically get all the details required to connect to this network, and the system who provide all this information is known as DHCP server, and this node is considered as DHCP client. So we will see how this information will be exchanged, what is the interaction between DHCP and DHCP server and client. So first of all, we will see how many entities are there in DHCP protocol. So first one is the DHCP server. So this server actually provide IP address on demand. Whenever a new machine is connected to network, it will provide the IP address to that machine for a particular duration. So it offer actually IP address on lease. So once that duration is expired, this server can assign same address to other system. So this server also maintain a data storage. So in that data storage, this server maintain how many addresses are already allotted and how many addresses are available. Second entity, we are having DHCP client. Any device which is going to connect to network and which is going to fetch details from DHCP server is considered as DHCP client. And third one is a DHCP relay agent. What is meaning of this one? In a organization, make a when we establish networks, so there are chances that there are a number of local area networks, but for all local area networks we want to install only a single DHCP server. So in some LAN there won't be any DHCP, so whenever in those LAN new machine come, those machines send a DHCP request, so that DHCP request has to be forwarded to designated DHCP server. So in every LAN there will be a agent that is known as DHCP relay agent. So what is the role of this agent? In case if DHCP server is not in the current local area network, so this device will be there, this machine will be there, and this machine will forward request to the DHCP server who are in another LAN. So using DHCP relay agent we can configure multiple lane with single DHCP server. So total entities we are having 3: DHCP server who provide network details, DHCP client who is requesting for those details, and DHCP relay agent who forward DHCP request to DHCP server if that DHCP server exists or available in another LAN. So let's start how they interact, DHCP server, DHCP client. So this machine we are considering, this is a DHCP server, and these machine already connected with this network, and we are assuming this machine is uh, connected to network recently and is not having any IP address. So this node will send a message, or actually it will broadcast a message. That message is known as DHCP discover. So because this is a new device, this device is not having any idea what is the server DHCP server IP address or to whom I should ask. So it will broadcast that I am looking for DHCP server, who is he. So it will broadcast a DHCP discover message. So these packets will go to every node in the network. So when this DHCP server receive this DHCP server discover message, this server machine would know that someone is looking for me. One more thing to consider: when this node is sending these packets, in these packet as a source address it will be included 0, because this node doesn't know its own address in the beginning. So source address in these packet will be given as 0. Now DHCP discover message when received by server will reply it to that targeted machine. How? There was no source address in this packet, so this server will use the hardware address of this machine. So the next packet server will send uh, so this is actually DHCP offer. This is not a this is wrong, this is mistake. So this is DHCP offer packet, this is not DHCP discover packet. So server when receive DHCP discover packet from client, it will send a reply to only that client, and that packet is known as DHCP offer. So this DHCP offer will be so this is the DHCP offer. This packet will be sent by the server to the client. So what does this DHCP offer packet contains? It contains the IP address of this server plus which IP address this server is offering to this machine. So all these details are included in this packet. So this node received DHCP offer. In case if a network is having multiple DHCP servers, so this machine will receive multiple DHCP offer packet. Now it's up to this machine which offer it will select. So now this machine has received DHCP offer in response to DHCP discover packet, and let's say this machine is agree with the IP address offered by this server. So in that case this machine will send a packet that is known as DHCP request. So this DHCP request message actually broadcasted. This node no okay IP address of DHCP server, but still it is broadcasting this packet. Why? It might be possible that other DHCP server also has sent its offer to this node. So when those DHCP server receive this broadcasted packet, they would know that they are not selected for that machine. So whatever offer they have given, that is declined. So this server has received DHCP request. It means this server would know client is interested to take that offered IP address. So now next step, what the server will do, the server will check whether that offered IP available or not. So it will try to see whether this IP is available by using ICMP packets. So in case if that IP address is available, it will make a entry in the database in its persistent data storage that this IP address now won't be available, and it will prepare a packet DHCP ACK. So this is a acknowledgement, and this packet will be sent to that machine confirming that whatever IP address you have offered to you is allotted to you. It might be possible that when this server received DHCP request message, and meanwhile that IP address is allotted to some other machine. So when this server received DHCP request from this node, it will check whether that IP is available or not. In case if that is not available, this server will send a DHCP NAC, negative acknowledgement. It means your request is not processed. So here we are considering offered IP available, and that is allotted to this machine. So this acknowledgement when received by this machine, this acknowledgement also receiving all having all the details required to connect to network. So this machine will set its ID. The DHCP client running on this machine will set its IP address to the address uh, embedded in this packet. So now this machine is configured. So now this machine can access network services. Now during their communication, at a time when this machine is about to move to another network or about to be disconnected from this network, so at that time this machine will release its IP address. Once its work is done, when they are about to move, they are about to disconnect it. So in that case, this node will send a DHCP release packet to this server. So when this server receive a DHCP release packet, it will mark that entry which it has already previously created, that this IP address is not available. Now it will mark as a available. This IP address is available. Now there is one more message type for DHCP, that is DHCP inform. What is that? It might be possible that we are having a DHCP server and a new device which is newly connected to the network. That device actually configured by administrator manually. We are having a DHCP server, but still that configuration actually done manually, and this person has supplied some IP address or all the details to this machine. So whenever such kind of scenario happens, this machine actually send all the networking details to the DHCP server. So there won't be any kind of inconsistency. If there is no DHCP inform mechanism, so what will happen? This person actually manually configured this machine, so DHCP server is not having any idea whether this IP address is allotted to someone. So from point of view DHCP server, this IP address is free, and it might be possible that it will allot same IP address to another machine. So to make data storage at DHCP server consistent, this node will send a message DHCP inform to inform DHCP server that the my configuration has been done manually, and the IP address given to me is 16. So please mark this IP address as unavailable. So this is the way how DHCP works. Thank you very much.